We're going to be looking at 7.3, proving that a quadrilateral is a parallelogram. These are very similar to the properties of parallelograms. They're just the reversed way. So there's several different ways that you can show that you have a parallelogram. The first way is the opposite sides are parallel, and that's just your definition of a parallelogram. The next is to show that both pairs of opposite sides are congruent. The next one is that the opposite angles are congruent. Again, as you guys can see, these are just converses of what we did with the properties of parallelograms. So the converse, remember, is just the flip. 4, this one is not necessarily a property, but this is the one that's different, and that's that you have an opposite pair, one pair with congruent sides, and that pair is also parallel. That one is, like I said, one of the ones that's not necessarily a property, so it's not a converse, as you guys can see there. And then the last one is showing that the diagonals bisect each other. Again, another converse. So those are the different ways that you can show that you have a quadrilateral that's a parallelogram. When you are taking your quiz and your test, I'm not looking specifically for that you know that it's the opposite angles converse, or I just want you to be able to apply that information to be able to kind of figure out, do you know it's a parallelogram? So example 1, since we have those there, just state which theorem proves the quadrilateral is a parallelogram. So on that first one, we know that this is a converse. I know technically it says parallelogram, opposite angles converse, but you could do converse of, that's totally fine as well. So converse of parallelogram, opposite sides. The next one, I can see I've got opposite angles that are congruent. So converse of parallelogram, opposite angles. Next one, I've got diagonals, and those are congruent. Parallelogram, diagonals, converse. Again, these are all just properties. You're just going the reverse way to show that it is, in fact, a parallelogram. So on this one, now you're looking more at the algebraic side of this. When you're looking at this, we can see that your opposite sides would be congruent. So 3x minus 32 would equal 2x, and you're just solving for x. X is 32. And then on the y's, obviously setting those equal to each other. And you'd get 29. Example 3, again, same setup. You're just using that information to show that you have a parallelogram. We already know, and the reason why you were doing it, it's just like when we'd have the parallel lines and those different angle pairs, it was like the converse of AEA. So you're doing all the math work to show that those are congruent in order to prove that you have what you do. So on this one, 6x equals 3x plus 2. This one, it's all right to have a fraction. We don't care. Not a big deal. And x equals 23. So as you guys can see, the properties of parallelograms and proving that you have a parallelogram, those are tied very hand in hand together. So it makes sense that we have all of this together in one.